proceed with the chemical properties of alkali metals. And in chemical properties of alkali metals, number one, we are going to check the reaction with air. The reaction with air. And we know the part of air that is going to react is the active part of air. That is now the oxygen. How do alkali metals react with air? So we know a metal plus an oxide, a metal plus oxygen, it will form a metal oxide. Therefore, if we start with lithium, it reacts with oxygen to form lithium oxide. It will react with oxygen to form lithium oxide. That is now the chemical equation. Is lithium, which is solid, that is now its metal, plus oxygen gas, it will form lithium oxide, which is a white solid. If we balance the chemical equation, we have to put 2 here, and then we have to put 4 here. 4 lithium, 2 oxygen, 2 oxygen. Therefore, the equation is automatically balanced. So, when lithium reacts with oxygen, it's going to form lithium oxide, and this is now the balanced chemical equation for that reaction. We have number 2, sodium. How is sodium going to react with oxygen? That is now with air. Sodium, it burns with a yellow flame. Sodium burns with a yellow flame to form a yellowish white solid. That is now white solid of sodium oxide. So when you burn sodium in air, it is going to produce a yellow flame. It will burn with a yellow flame to produce now a yellowish white solid, a white solid that contains some small particles which are yellow. So that is now that solid that contains the yellow particles, and the white powder is the sodium oxide that we have. And the chemical equation is sodium, which is a metal solid, will react with oxygen gas, to form sodium oxide, which is solid. But the question is, how are we forming lithium oxide? How are we forming sodium oxide? We know in the first chapter we talked about how to derive the chemical formula. We know lithium is an ion, and oxide ion is like this. When it comes to the formation of a chemical formula, the valences are interchanged, where lithium will take the 2 of oxygen and oxygen will take the 1 of lithium. Therefore, lithium will be 2 and oxygen will have 1. And that is the formula of lithium oxide that we have there. For sodium oxide, we know sodium is positive 1. That is now the charge is 1 positive. When it comes to the oxide, it has 2 negative. When the valences are interchanged, sodium will take the 2 of oxygen and oxygen will take the 1 of sodium. And now the formula of sodium oxide will be like that. That is how we are deriving the formulas of the oxides of the alkali metals that we have. So here we have lithium reacting with oxygen to form lithium oxide, and this is the chemical equation which is balanced. When sodium is reacted with oxygen, it is going to form sodium oxide. That is now when we are reacting sodium with limited oxygen. When the oxygen is limited, that is the time we are going to form sodium oxide. But the question is, when we have enriched supply of oxygen, what type of oxide are we going to form? We are going to form what we call sodium peroxide. Sodium burns in air enriched with oxygen, to form sodium peroxide. That is now sodium, which is solid, plus oxygen gas to form sodium peroxide. That is now solid. This is the formula for sodium peroxide. This is sodium peroxide. if we try to balance the chemical, and this is now the enriched supply for oxygen. So if we try to balance the chemical equations, here we have 2 sodium, we have 1 sodium, we have 2 oxygen, 2 oxygen. That means the oxygen is balanced. But we require 2 for the sodium on the reactant side. We put 2 here, and I think the equation is now balanced. Sodium 2, and then oxygen is 2, and then the equation is automatically balanced. For this one, we will just require a 2 here, and we will require a 4 here, and that will make the equation balanced. So this is what occurs when lithium reacts with oxygen. It will form lithium oxide, and when sodium burns in air which have a limited supply of oxygen, it is going to form sodium oxide. That is now a limited supply of oxygen. When we talk about the burning of sodium in enriched supply of oxygen, that is now when we have more oxygen atoms in the air, sodium will react with the oxygen to form sodium peroxide. That is number 3, potassium. So potassium, it burns with a lilac flame. It burns with a lilac flame, a flame that resembles a purple color. It resembles a purple color, and it is known as lilac. So the color is a bit lilac, and it looks alike like purple. So potassium burns with a lilac flame to produce a white solid, which is potassium oxide, which is potassium oxide. So potassium, we have solid plus oxygen gas to form potassium oxide. If we balance the chemical equation, since they belong to the same group, the balancing will be the same. 4 potassium plus 1 oxygen molecule to form 2 potassium oxide atoms. That is now the reaction between potassium and oxygen. So that is now generally the reaction that occurs between oxygen and the alkali metals. Let us proceed to the second reaction, done with water. What are some of the observations that are made when lithium atom, a piece of lithium metal, is placed on the surface of the water? What is going to be observed when a piece of sodium metal is placed on the surface of the water? And what is going to be observed when a piece of potassium metal is placed on the surface of the water? So let us have a summarized table that is going to give us a brief description on what is going to occur when we have the metal for this column. The other column is going to be observation made when placed in water. That is the second column. And the third column, we are going to have the rate of reaction. When we place it on the surface of the water, how is it going to react? So the first metal, let us talk about lithium. When it is placed on the surface of the water, the first thing that is going to be observed is that the lithium metal is going to float on the surface of the water. It floats on the surface of the water. That is the first observation that is made. The lithium metal is going to float on the surface of the water. The second observation that is made, a colorless gas is produced. And number 3, the third observation that is made when lithium metal is placed on the surface of the water is that the resulting solution turns red litmus paper to blue. It turns red litmus paper to blue. Therefore, what can we say about that property? We can say that the solution formed is an alkaline solution. When lithium reacts with water, it will form lithium hydroxide, which is an alkaline solution. And that solution will turn a red litmus paper to blue. So the observations that are made when lithium metal is placed on the surface of the water is, number 1, it is going to float on the surface of the water. Number 2, it is going to produce a colorless gas. And number 3, the resulting solution will turn a red litmus paper to blue. But the question is, how can you test the colorless gas that is produced when lithium metal is placed on the surface of the water? I think that one was taught previously in water and hydrogen, that is in Form 1, how to test hydrogen gas. Remember, when we react a metal plus water, we are going to have metal hydroxide plus hydrogen gas. So that means the colorless gas that is produced when lithium metal is placed on the surface of the water is a hydrogen gas. But how can it be tested? When you take a gas jar containing hydrogen gas and you insert a burning splint, it is going to burn with a pop sound. It is going to burn with a pop sound. And that is the test for hydrogen gas. That's now the first method we have seen when it is placed on the surface of the water. Let us proceed to sodium. What happens when sodium is placed on the surface of the water? For sodium, the first observation that is going to be made is, number one, it is going to dart on the surface of the water. It darts on the surface. It darts on the surface of the water. It darts on the surface of the water. That means, if I use a layman's language, that is now jumping. So it is going to dart on the surface of the water. But now, when it is going to dart on the surface of the water, it is going to melt into a silvery ball. It darts on the surface of the water as it melts into a silvery ball. That is what is observed. That is the first observation. Number two, a colorless gas is produced, of which we talked about in lithium. That's colorless gas, and we said it is hydrogen. And we also explained how it is tested. The third observation is the resulting solution turns red litmus paper to blue, because we said when a metal reacts with water, it will form a metal hydroxide. So therefore, sodium reacts with water to form sodium hydroxide plus hydrogen gas. So the resulting solution is sodium hydroxide solution that will turn a red litmus paper to blue because it's a basic solution. So those are the observations that are made for sodium. When we proceed to potassium, that is number 3 metal, potassium, number 1, it darts on the surface, just like sodium. It darts on the surface of water. It darts on the surface of water as it melts into silvery ball. The second observation is a colorless gas is produced, and the third observation is the resulting solution turns red litmus paper to blue. What is the resulting solution? The resulting solution is potassium hydroxide, and it is an alkaline solution that will turn a red litmus paper to blue. So now we have seen the observations that are made in the 3 metals when they are placed on the surface of the water. Let us now check the rate of reaction. When we place lithium on the surface of the water, the hissing sound that is produced is as a result of the colorless gas produced. But now, a small hissing sound is produced when we use lithium. But when we use sodium, the hissing sound increases. But when we use finally potassium, the hissing sound increases compared to that of sodium. Therefore, this means when we react lithium, sodium, and potassium will be more reactive to water compared to sodium and lithium. And when it comes to between sodium and lithium, sodium will be more reactive to water compared to lithium. Therefore, lithium is the least reactive with water, and potassium is the most reactive with water. Therefore now, the reaction between lithium and water can be rated as vigorous. It can be rated as vigorous. The reaction between sodium and water can be rated as more vigorous because it is more reactive than lithium. And the rate of reaction for potassium can be rated as explosive, because it is the most reactive. Therefore, when this reaction is carried out, potassium metal should not be reacted with water because it is explosive. it can cause a lot of damages. And when lithium and sodium metals are tested, a small piece of sodium and lithium metal should be used because the reaction is vigorous. Those are now the observations that are made and the rates of reaction when lithium, sodium, potassium are reacted with water. We are going to have lithium, which is solid, will react with water, which have a chemical state which is liquid, will form lithium hydroxide, which is an aqueous solution, plus hydrogen gas. Let us balance the chemical equation. Here we have 2 hydrogen, here we have 3 hydrogen, here we have 1 oxygen, 2 oxygen. The oxygen is balanced. For the hydrogen, we require 2 here, 2 for water, and 2 for lithium. I think the equation is now balanced. 2 lithium, 2 times 2, that is 4 hydrogen, 2 plus 2, 4 hydrogen, 2 oxygen, and 2 oxygen. The equation is balanced. For sodium, it will take the same format, and the balancing will be the same. Plus 2 molecules of water to form 2 sodium hydroxide plus 1 hydrogen gas. That is now the balancing. For potassium, it will take the same format still. It will take the same format, the same balancing. Potassium hydroxide aqueous plus hydrogen gas. But the question is, why do they have the same balancing? This is because lithium, sodium, and potassium, they belong to the same group. Therefore, they lose 1 electrons from the outermost energy level. Hence, they will have the same balancing during reaction. So therefore now, this is the reaction between alkali metals and water. Reaction with chlorine. Let us start with the lithium. Before we start with the lithium, generally, we understand that the reaction between metal plus chlorine gas, it will form a corresponding metal chloride. Therefore, if we react lithium plus chlorine, we are going to form lithium chloride. If we react sodium plus chlorine, we are going to form a corresponding metal chloride, that is sodium chloride. If we react potassium with chlorine, we will form a corresponding metal chloride, that is potassium chloride. So if we start with lithium, which is solid, it will react with chlorine gas, which is a diatomic gas, to form lithium chloride, which is also a white solid. So to balance the equation, we require 2 for lithium chloride and 2 for lithium, so that the equation can be balanced. Number 2, we have sodium. Sodium, when it reacts with chlorine gas, it's going to form sodium chloride, which is a white solid also. The sodium chloride is also known as table salt, or it is also known as the common salt. And we are going to discuss its use under the uses of alkali metals. Number 3, we have potassium, which is solid, plus chlorine gas. It will form potassium chloride, which is a white solid also. We require 2 here, 2 here, 2 here, 2 here. The equations are balanced. So that is how the reaction between chlorine and alkali metals occur. Generally, what is going to guide you is that when a metal plus chlorine reacts, it will form a corresponding metal chloride. Lithium plus chlorine, a corresponding metal chloride, which is lithium chloride. Sodium plus chlorine, a corresponding metal chloride, which is sodium chloride. And potassium plus chlorine, it will form a corresponding metal chloride, which is potassium chloride. And those are some of the chemical properties of alkali metals. The reaction with water, the reaction with oxygen, and the reaction with chlorine. Uses of alkali metals. We are going to discuss some few uses of alkali metals. The first use, the previous explanation that I was giving was the reaction between chlorine and alkali metals. That is now the reaction between sodium and chlorine. We say it will form sodium chloride. But we say the other name for sodium chloride is table salt or common salt. Since it is table salt, we know where table is used. Table is used in homes. Therefore, what is the function of sodium chloride in homes? It is used as a food additive. Sodium chloride is used as a food additive, so that it can make the food have a taste. That is the first use of alkali metals. Sodium chloride is used as a food additive. The second use of alkali metals is lithium. Lithium is used in manufacture of high strength glasses. Is used in manufacture of high strength glasses and ceramics. That is the use of lithium. It is used in the manufacture of high strength glasses and ceramics. Another use for lithium, that is now use number 3, lithium chloride. Lithium chloride is used in manufacture of dry cells. Lithium chloride is used in manufacture of dry cells. Where are these dry cells used? Dry cells used in mobile phones. They are used in mobile phones. They are also used in laptops. They are also used in stopwatches. They are used also in stopwatches. That is now another use of lithium. Lithium chloride, which is a compound of lithium, is used in the manufacture of dry cells, which is used in mobile phones, laptops, and stopwatches. Number 4, we have sodium. Sodium vapor. Sodium vapor is used to produce glow in street lights. That is the function of sodium vapor. It is used to produce glow in street lights. That is another use for alkali metals. Another use for alkali metals is a mixture of sodium and potassium is used as a coolant in nuclear reactors. A mixture of sodium and potassium is used as a coolant. In nuclear reactors. That is use number 5 for alkali metals. If we add some more uses, use number 6, we know a mixture of sodium hydroxide, that is caustic soda, and carbon disulfide is used in the manufacture of silk, which is known as rayon. A mixture of sodium hydroxide. The other name of sodium hydroxide is caustic soda. A mixture of sodium hydroxide and carbon disulfide that doesn't contain any oxygen is used in manufacture of silk, known as rayon. That is another use of alkali metals. Another use of alkali metals is sodium. Molten sodium is used in the extraction of titanium metal from titanium 4 chloride. Molten sodium is used in extraction of titanium. From titanium 4 chloride. That is now the alkali metals, their chemical properties, physical properties, and all their uses. And inshallah, we are going to meet next lesson so that we can further discuss the chemical properties and the trends regarding the alkaline earth metals. And after that, we are going to check the group 7 elements, which are the halogens. And let us meet next lesson, inshallah. Assalamu alaikum.